Here is an algorithm for identifying what elements in an agent's classification knowledge may be potentially responsible for its failure. Let us look at the problem of identifying the false success elements. As we said earlier, potentially the agent may receive a set of positive experiences and a set of negative experiences, not just one positive or one negative. First, take the intersection of all the features that are responsible for all the false successes. A false success, again, is something that we identified as success but was not a success, like the pail. We identified it as a cup, but it was not a cup. First, take the intersection of all the features present for all the false successes. False success is an object that the agent identified as a success, but in fact was false. Like the pail, the agent identified that it was a cup, but it wasn't. Then take the union of the features present for all the true successes. A true success is something that the agent classified as a success and indeed was a success. Now remove all the assertions in the union of the true successes from the intersection of the false successes to identify those elements that are present in the false successes only.
So to put that differently, start off by gathering together anything that's ever present in a false success. Then gather together everything that's true for every single true success. Remove the things that are true for every true success from the things that are ever true for any false success. In that way, we get a list of only the things that are true for some false successes.
Similarly for identifying suspicious true success relationships, except that here the operations are in reverse.
So similarly, here we gather together everything that's ever true about any true success, and then gather together the things that are true for every single false success. So every single false example has these things in common. Then we remove the things that every single false example has in common from the things that are true for any true example.
As you can see, we are taking unions and intersections of features characterizing different examples. The number of examples, both positive and negative, needed for this algorithm to work well depends upon the complexity of the concept. In general, the more features you have in the description of the objects, more will be the number of the examples you will need to identify the features that were responsible for a failure.